Hello guys, so today we are gonna solve today's LeetCode problem, that is the minimum cost to convert string. Like this is a, like we can say, a medium type question. Like in the first instinct you don't have the idea like how to proceed with it, but once you get the logic behind it, it will be very simple for you. So let me start with the explanation. So basically what we are given, we have been given two strings, like first one is source string and second one is target string. So basically we also have given a mapping, like from A to B. We need, if we want to transform from A to B, then cost of 2 will be used. Likewise different mappings were given, and like basically we need to convert the source string into the target string. Overall we have this objective. So like how we can proceed, like suppose we have SNT ABCD and ACB. Like if we put a pointer on A and A, like both for traversal, for A and A it will be equal, so no cost will be required for transformation. And for B, when pointer moves to B and pointer moves to C, so here we can see for B to C we have like a mapping and it will cost us 5. That's why I have written 5. And when pointer moves to C, and here in the string T pointer moves to B, then for C to B we will check the mapping. Yes, we have the mapping, so again we are adding plus 5. Same for D. Do we have a mapping from for D to E conversion? Yes, we have. So overall the cost will be like 30. But this is a valid solution, but in LeetCode we have to identify the minimum cost, and so this will like not be the correct one. So let's proceed how we can solve this. Like you can see, B to C, sorry, C to B, C to B we have 5, but we can also reach 1 minute. Yes, we can also reach C to B from C to E, E to, means C to E, and E has always a mapping of B. So directly C to B we can like traverse from C to E and then E to B likewise. So that's why I have written 5 for B to C. It has only one possible path, direct connection. So 5 will be required. Same for 20. But for C to B, we have a different path, so we can follow that. And the cost will be for C to E, it will be 1, and E to B, it will be 2. So overall, it will be 28. And this is the minimum cost you will be required for the conversion. So this was the like overall view, and let's proceed for further explanation. Like how you, 1 minute, yes, like here you can visualize like cost. What is it, like A to B? For A to B mapping we have cost 2, B to C we have 5. So you can like think of it like a graph. We have two nodes A and B, of which the from going for it from A to B we have to pay 2 rupees. Like this we can visualize as a graph, directed graph. Like we have edge from A to B, what is A to B, similarly for B to C likewise. So we basically, oh sorry, so basically we have built this type of graph we can build from the visualization. And as I have told you, cost can be visualized as edge and like weights of different parts. So we can like solve it. So here you can see the diagram. It is like we have been given the paths, shortest path. So let me show you the diagram. Like from D to E we have only one path, so we have to take 20. Similarly for A to B we have to like take 2, since only one path. That's why in the, that's why here we have like taken 5 and 20 fixed, and for C to B we have like given the done the transformation. So like from C to B you can move like direct C to B, which will cost 5, or C to E, E to B, 1 plus 2 3. So we will pick the minimum or shortest path. Likewise, how we can formulate this, like we have to like find the shortest path from each node to all other nodes. So what two algorithms we can use, like Dijkstra and Floyd Warshall, as both are like for finding the shortest path. So But we will use a Dijkstra because Floyd Warshall we know when we have to deal with the negative edges, then we basically use the Floyd Warshall. So what we need to build here, like from the yes from the original and change the array, we basically need we basically need to build our distance vector. Like it will show, sorry, it will be like we have to build the, here we will have to like put adjacency list. We have to build like from u to v what is the cost and what is the, like for 1 minute, yes, we have to build the adjacency like this for adjacent for u, the what is the weight for reaching v and our neighbor node which is the v. And what I was talking about distance vector was like we have to store the distance of each node to all other nodes. Like we have been vector will be like this, let me show you. For 0, sorry, from yeah, from node a, distance of 0 1 2 3, like different b c d, like all different nodes, path will be like this. We will have path, shortest path. So let's go through the code what we need to build. Like this was the problem. Parameters we have been given source array target string, sorry, string it will be, and like we have change vector cost and like origin. So basically we are building adjacency list. Initially we require it for like traversal during the Dijkstra. For that we are building an adjacency list, and its structure will be like adjacency list of adjacent of u equal to weight comma v, like it will be the cost. So like we are building a unidirectional adjacency list, so only adjacent of u dot pushback cost of ib. If we have to multi-directional, then we should have done adjacent of v dot pushback also. So basically what is u? U is basically the source node which we are taken here from here a minus a, which will be like 0. So this time in this time we are creating our adjacency list, and along with that we are calculating the distance of each node from the all other nodes, shortest distance I mean to say. It is like 26 size, sorry, 2D vector of 26 into 26 cross 26 size, basically all initialized to int max. Since we want the shortest distance, that's why we are initializing it to int min. We also can do, but that will be like sometimes it can give overflow error. Following that, yeah, we are calling Dijkstra here for 26 times because we need to calculate the shortest distance of all nodes from a node. Like 26 nodes, we have to calculate the shortest distance. That's why we are calling it for 26 times. This part we will go further. Before that, we need let me explain the Dijkstra. We know Dijkstra, it basically has a source node, and which we are given like here. We are pushing the each node to calculate the further distances. And initially we put the source node as 0 0 because if we are standing at 0, then the weight will be 0, and of course the source node will be like 0. Sorry, yeah, distance of at this is, yeah, it will be 0. Like after that we need to create a priority queue, and then we have to push the priority queue 0 comma source, since source is the initial node on which we are standing. And we do the common priority queue thing like we do in Dijkstra. Like initially till we are gonna search till priority queue dot got empty. So first of all we will access the node using the pq dot top, and in the top we have like, you can see first is weight and there is the node. So we have access it the node using this. After that we are gonna pop the topmost node. After that we are gonna use an iterator to iterate through the adjacency list for particular node we have got from here priority queue. Like initially it will be a source, then we are gonna find its neighbor by, and how you have seen like adjacency list structure, yeah, this was the neighbor and this was the cost. Likewise int neighbor equal to it dot second, same for weight it dot first. And this is typical Dijkstra thing we do, like calculate the distance, like distance of source to the neighbor, is it greater than distance of source, uh, that like distance of current node from source plus the weight we have been used from going from u to v. This is typical Dijkstra. We basically do update the weights, sorry, update the shortest distance. After that, we push the distance of the new neighbor and then the neighbor also. So we go on doing like for every node. So talking about the complexity of the code, like here it is, in talking of space complexity is big of 26 size vector. It is as good as like constant. Similarly, we can say for here constant. And yeah, for travel, and yeah, last we are basically gonna traverse through the source to check if the current node has not been visited, like it is uh, sorry, yeah, if it still not visited means the shortest path is not possible, so we are returning -1, else we are adding the weight to the, sorry, else we are adding the distance to the cost which we have put it here like answer. At last we are returning the answer. So overall time complexity will be like big of n for traversing this string, so n. And yeah, we can say like here big of for Dijkstra we know, yes, for Dijkstra for each node it takes like e log v, but here v is 26, so like e log 26, where log 26 will be like constant and we have to perform this operation for 26 times since 26 nodes are there. So overall it will be like uh, equal to e. So total complexity will be like n plus e, and as I have told you space, it will be like big O of e, since we can think this will be a, these are constant, and like in case of Dijkstra we are, I am saying like at max it can store e vectors, sorry, e nodes, e edges, sorry,